Today, almost everything runs on batteries, electric vehicles, solar systems, mobile phones, and power backups. But have you ever wondered who protects the battery from damage? Who decides when to charge, discharge, or stop? The answer is Battery Management System, commonly called BMS. In this video, you'll learn what is BMS, why BMS is required, how BMS works step by step, and where it is used in real life. A battery management system is an electronic control unit that monitors and controls a battery pack. It acts like the brain of the battery. Without BMS, lithium-ion batteries can overcharge, overdischarge, overheat, catch fire or explode. Why BMS is required? Lithium-ion batteries are powerful but very sensitive. Even a small mistake in voltage or temperature can permanently damage the battery. That's why BMS is required to protect the battery, improve battery life, ensure safe charging and discharging, balance all battery cells. Main parts of BMS. A typical BMS consists of four main blocks. Voltage sensor measures each cell voltage. Current sensor measures charge and discharge current. Temperature sensor monitors battery temperature. Controller, microcontroller, takes decisions. All these parts work together to protect the battery. How BMS works? Step 1. Voltage monitoring. BMS continuously checks the voltage of each cell. If voltage goes above or below safe limit, BMS reacts immediately. Step 2. Current monitoring. BMS measures how much current flows during charging and discharging. If current is too high, BMS disconnects the battery. Step 3. Temperature monitoring. If battery temperature rises beyond safe value, BMS stops operation to prevent fire or damage. Step 4. Decision and control. Based on sensor data, BMS controls switches, MOSFETs or relays to allow or stop current flow. Cell balancing in BMS. Battery pack contains many cells. Over time, some cells charge faster, some slower. This imbalance reduces battery life. BMS solves this using cell balancing. Types: passive balancing, active balancing. Balanced cells is equal to longer battery life. BMS in electric vehicles. Energy storage systems. In electric vehicles, BMS plays a critical role. It protects high-voltage battery packs, estimates state of charge, SOC, communicates with motor controller, improves driving range. EV cannot run safely without BMS. Applications of BMS. Battery management systems are used in electric vehicles, solar energy storage, UPS and inverters, mobile phones and laptops. What is SOC? State of charge. State of charge tells us how much energy is currently left in the battery. It is similar to the fuel gauge in a petrol vehicle. Example shown on screen. SOC is equal to 75% battery is 75% charged. What is SOH? State of health. State of health indicates the condition of the battery over time. It shows how much capacity the battery has lost due to aging. Example shown on screen. SOH is equal to 90% battery is still healthy. How BMS calculates SOC and SOH? The BMS uses voltage, current, temperature data and intelligent algorithms to estimate SOC and SOH accurately. Accurate SOC and SOH is equal to better range prediction plus battery safety. Charging and discharging control in BMS. This slide explains how a BMS actually controls current flow using MOSFETs, which is a core practical concept for EVs, solar batteries, UPS, and interviews. Charging control. Left side green. During charging, the BMS checks voltage, current, and temperature. If all values are within safe limits, the BMS turns on the MOSFET and allows current to flow into the battery. Logic. Safe condition is equal to MOSFET on, charging allowed. Discharging control. Right side red. During discharging, the BMS again monitors all parameters. If the battery reaches a low SOC or unsafe condition, The BMS turns off the MOSFET and stops current flow. Logic. Unsafe condition is equal to MOSFET off, battery protected. So this was the complete explanation of the battery management system. Remember, BMS ensures safety, performance and durability of modern batteries used in EVs, solar systems and backup power. If this video helped you, like, share and subscribe for more electrical engineering concepts.